The moon is our natural window to the universe. It is a mysterious world in itself. Let us start near to reach far into the universe. The moon shows violent scars on its surface formed in its remote past. In this presentation, let us explore the basic facts of the moon before we go into the technical aspects concerning the same in subsequent videos. Our cosmic connection with the universe begins with the age old companion, the moon. The pale blue dot on which we live is indeed 12,742 kilometers in diameter. The moon measures around 3,462 kilometers. Look at this picture. Observe. It shows the continent of Africa with the island of Madagascar, the Red Sea, the Arabian Peninsula, Persian Gulf, and the ice continent of Antarctica in the South Pole. On the right side of Africa, there is Indian Ocean, and on the left side, the Atlantic Ocean. We also can see cloud formations and distinct coloration of the land surface, showing the desert regions of northern Africa and Arabia. The pale blue dot is a very big planet indeed. The Earth is a little more than 3.5 times the diameter of the Moon. Imagine the subcontinent of India measuring approximately 3,000 kilometers north south. It can be conveniently placed within the Moon's diameter. The Moon is the fifth largest satellite in the solar system. The average center to center distance from the Earth to the Moon is 3,84,403 kilometers, about 30 times the diameter of the Earth, more than 100 times the Moon's diameter. The Moon is 400 times smaller than the Sun, and the Sun happens to be 400 times farther away than the Earth-Moon system. That is why the Moon and the Sun appear to be of the same angular diameter in our skies. Now observe the Moon. It shows a mix of light-toned regions and darker irregular blotches scattered with varying sizes of craters, supposedly caused by the impact of foreign bodies like asteroids, meteoroids, and comets. These craters appear like dark and bright circular pits surrounded by outthrown rays of bright ejecta, forming into what is known as the lunar rays. If you look at this picture of the Moon, you see the directions marked as north, south, east, west. Imagine yourself standing on the Moon facing north. As on Earth, east is on the right hand side and west on the left hand side with south behind. The east on the Moon face the west in our sky, and the west on the Moon face the east in our sky. Also, the Moon appears upside down in the telescopes. Our surface is pockmarked with craters of all sizes. There are bright areas called highlands, which are heavily cratered, and dark areas called maria, which are relatively smooth. It means sea in Latin. It's not a sea of water, but highly fluidized and solidified basaltic lava. The Moon is in fact a dry, airless, barren place. The mass of the Moon is about 1 by 81th that of the Earth. That is only 1.2% of the Earth's mass. In fact, the Earth weighs 81 times greater than the Moon. The diameter of the Moon, as we said earlier, is one-fourth that of the Earth, which is a very large fraction of Earth's diameter, because the Moon's density is only 3.34 grams per centimeter cube, and the Earth's density is 5.51 grams per centimeter cube. That's about 60% of the Earth's density, and therefore its surface gravity is one-sixth that of the Earth. Moon presents the same phase to the Earth due to synchronized or captured rotation. The Moon has absolutely no atmosphere. The Moon presents the same phase to the Earth because of what is called as tidal influence of the Earth on the Moon. The Moon also causes tides on Earth, which is so apparent in the oceans of the Earth, causing low and high tides. It also deforms the land by about a feet, which we cannot perceive. The Earth being a much more massive object than the Moon, it has a far more greater effect on the Moon causing tides which deforms the satellite moon, which has resulted over a period of millions of years in the moon being captured by the Earth's gravity and not being allowed to rotate on its axis as it was spinning fast in its initial days. It got into synchronized orbital motion, and rotation got synchronized with the revolution of the moon around the Earth. So the moon completes one rotation by the time it takes one complete revolution around the Earth, which is called synchronized rotation. Sidereal month is the time the moon takes to complete one full revolution around the Earth with respect to the background stars. And synodic month or lunar month is longer than the sidereal month. A sidereal month lasts 27.322 days, while a synodic month lasts 29.531 days. In other words, the moon from one new moon to another new moon, it takes 29.531 days. That is the synodic month. On a new moon day, the moon happens to be in between the Earth and the Sun. And as the moon revolves around the Earth, and since the Earth itself is moving around the Sun in its orbit, the moon takes about 27.322 days to completely revolve around the Earth, 360 degrees around the Earth. But since the Earth itself has traveled around in its orbit around the Sun, the moon has to travel an extra 30 degree to come in between the Earth and the Sun, which is called the synodic period, and it is a little longer than the sidereal period. The synodic period is 29.530 days, or 29 days, 12 hours, and 44 minutes. That is from a new moon to another new moon, the synodic period. An interesting phenomenon that we observe in our skies is the growing phases of the moon. The moon sometimes appears crescent, sometimes it appears to be in the state of dichotomy, that is half moon, then it appears as a gibbous moon, and sometimes the phases grow and sometimes it becomes less and less. So the growing phases are called waxing crescent and waxing gibbous moon, and then the reducing phases of the moon are called waning gibbous moon and waning crescent moon. From new moon to full moon, the moon travels around 180 degrees and it takes approximately 15 days. Day and night divider, the terminator, moves completely around the moon with the synodic period of 29.5 days. The varying speed of the moon in its elliptical inclined orbit causes librations of the moon, that is, the apparent slight turning of the moon in latitude and longitude. So we see 5/8 of the lunar surface in a period of one revolution of the moon around the Earth. Liberation in longitude makes for a little more of the view of the polar regions, and it's due to the eccentricity of the lunar orbit. And liberation in latitude makes for a little more of the view of the equatorial regions, and it's due to the inclination to the ecliptic. We shall discuss the topographical features of the moon in upcoming videos.